Hey guys, welcome to another Con Support video. This one is on two-step inequality word problems. All right, so it says you have $20 to spend on taxi fare. The ride costs $5 plus $2.50 per kilometer. Write an inequality to determine the distance in kilometers, D, you can ride for $20. So in two-step inequalities, you're going to have some constant that you start with, and then you're going to add to that some kind of growth rate, right? And then it's going to be compared to some total on the other side. So in this case, you got $20 to spend on taxi fare. That's the total amount you have to spend. The ride costs $5 plus 250 cents per kilometer. So which part of that's attached to a variable of kilometers? The $2.50, right? If you traveled 0 kilometers, you wouldn't pay any of that. Traveled 1 kilometer, you pay $2.50. Traveled 2, you pay 5, and so on and so forth. So this part here, this $2.50 per kilometer, is telling you that the variable term is going to be 2.5 times the variable. In this case, the variable is d, right? The number of kilometers is d. Right? So for every kilometer d, it's going to be $2.50. The $5 is the cost of the ride, regardless of how far you drive. That's a constant, right? Whether you drive far or short, doesn't make a difference. The distance isn't going to affect that initial cost of $5. So that's your constant. And you want to make sure that you don't spend more than you have. You only have $20, right? So that has to be that this total amount that we spend, right, has to be less than or equal to the 20 bucks. Is it okay to spend exactly 20 bucks? Sure, but you don't want to spend more than the $20, right? You want to spend less than or equal to up to that $20. Okay, so this is your correct inequality. And this is what is the maximum distance in kilometers you can ride for $20. So in this case, you'd actually solve this inequality, right? So you'd minus 5 to both sides, you get 15, then you divide by 2.5. So ultimately here, what you're really doing is you're just doing, let's just do a little calculator work here. You're just doing 15 divided by 2.5, which is going to be 6. So the most you could go is 6 kilometers. So you're going to put 6 kilometers in there. That's the answer. And that's it. I guess I could use that calculator. All right, so let's do the next one. All right, Janie has $3. She earns $1.20 for each chore she does and can do fractions of chores. She wants to earn enough money to buy a CD for $13.50. Write an inequality to determine the number of chores, C, that Janie could do to have enough money to buy the CD. All right, well, which of these things is attached to C? Since she already has $3, that doesn't change, right? That's constant. So that's a 3. She's got $3. But what is attached to the C is the $1.20 she's getting paid for each chore. So it's 1.2 as the multiplier, right? You're increasing her amount of money by 1.2 for every what? For every one chore times C. Okay, that expression represents the amount of money that she has, right? $3 plus $1.20 per chore. Now we're going to compare that to what she wants to raise. She wants to buy a CD that costs $13.50. So she needs to earn at least $13.50, right? She could earn more than that, but she has to earn at least $13.50. So that means that this dollar amount that she has on the left needs to be greater than or equal to the dollar amount she wants to target earning, 13.5. So this is your inequality, all right? And then it says graph the solution set to this inequality. Well, we got to take this value here. We got to move it around, right? Now, where is it going to go? Well, ultimately, if we wanted to solve this problem, right, we're going to want to just undo the plus 3, so minus 3. So what you get is 1.2. 1.2c is greater than or equal to 13.5 minus 3, which is going to be 10.5. And then you're going to divide by the 1.2. So ultimately what you're going to get here is 10.5, and you're going to divide that by the 1.2. Let me see if I can do that in a smaller way so it's a little easier for you guys to see. All right, you're going to divide that by the 1.2. So what we get is 10.5 divided by 1.2, and that's going to be 8.75. So what that's telling you is that she needs to complete 8.75 chores to get the amount of money she needs for this CD. So we got to start with 8.75 here. So that's 8, that's 8.5, that's 9. So 8.75 would be exactly halfway between 8.5 and 9. And we want this to go to the right. So that's funny, right? So there's 8.75. says switch direction. No, we don't want it to go to the left. We want it to go to the right. So let's go in the right direction now. And can she get exactly 8.75? Sure. We want a closed circle because if she did exactly 8.75, sorry, chores, she would get exactly $13.50 in all, right? So it says that she can do fractions of chores, which means that you can allow 8.75. If it said that she had to complete the chore to get paid, right? She had to complete the chore to get paid, then you'd have to start with 9, right? But because she can do parts of a chore, you can say that she needs to complete 8.75 chores. So this is the correct answer. Let's look at the next one, okay? The dance committee of Pine Bluff Middle School earned $72 from a bake sale and will earn $4 for each ticket they sell to the Spring Fling dance. The dance will cost $400. Okay, write an inequality to determine the number T of tickets the committee could sell to have money left over after they pay for this year's dance. Oh, that's careful. Money left over. You gotta think about that carefully. All right, so first thing you want to think about is the value here, 72, is a constant, right? They earned that from the bake sale. That's done. Has nothing to do with the tickets they sell. But they are earning an additional $4 for every ticket that they're selling, right? So 4 times whatever variable they chose for number of tickets sold, in this case, T. So 72 plus 4T is the expression that stands for the total amount of money they've raised. Now they have to raise $400, but it says that they want to have leftover money, which means they can't just get 400, then they would have nothing left over, right? We want to know how much the tickets would have to sell to have leftover money. So this total amount that they earn has to be not just equal to 400, but greater than the 400 because they want leftover money. So this is your inequality that you would write. And when you solve this, you would just solve it by, let's grab the calculator here, right? You would just solve it by subtracting the 72. So it's 400 minus the 72. And then you get 328. And then you're going to divide by the 4. So you're going to divide both sides by 4. And you're going to get 82. All right, so what is the answer? 82. What does that mean? They need to sell more than the 82 tickets, okay? More than the 82 tickets in order to get leftover money. So T less than 82, that's not going to work. T less than or equal, that's not going to work. Greater than or equal, it's not going to work because they don't want equal to. They don't want to have nothing left over. It's just greater than. That's it. And let's close that up. Next one. Joey Chestnut is trying to break his own record for eating the most whole hot dogs in 10 minutes. He needs to eat more than 72 hot dogs to break his record. After 1 minute, Joey has eaten 11 1/4 hot dogs. Let D represent the number of hot dogs Joey eats per minute for the next 9 minutes. Okay, so the 11 1/4 hot dogs is what he's already eaten. So that's a constant. It's not going to change. He's already eaten that. So we can see the 11 1/4 is a constant. All right. We know that the total number that he wants, the total amount of time he has is 10 minutes. So he's got 9 minutes left. All right. He needs to eat more than 72 hot dogs to break his record. So he has to get more than 72 in all. And D is the number of hot dogs that he's eating per minute, right? So each of those 9 minutes. So when we look at the expressions here, we've got 11 1/4, that's a constant. You got 9 times D, that's the amount of hot dogs he's going to eat in the remaining 9 minutes. And we want this value to be better than the 72, right? We want to have him eat more than the 72, right? So which inequality represents the number of hot dogs per minute Joey could eat for the last 9 minutes to break his record. So we have to make sure that this is greater than 72. Is it okay if this sum is equal to 72? No, then he ties his record. Now in this situation, they put the multiplier on the wrong thing. That 11 1/4 should be a constant, so that's just wrong. So it looks to me like it's obviously going to be this answer here because the constant is the amount he already ate in the first minute. Then it's 9 minutes times the amount he's eating per minute for the remaining 9 minutes. Together, that needs to be more than the record that he's trying to break, more than the 72. So A, that's the answer. It says, will Joey break his record if he eats 6 hot dogs per minute for the next 9 minutes? Well, let's test it out, right? What's 9 times 6? 9 times 6 is 54, okay? So 54 plus 11 1/4. Well, 54 plus 11 is going to be 55, 65. So it'll be 65 1/4. is 65 1/4 greater than 72? No. So will that be enough? No. That's it. Hopefully that makes sense and you guys understand how to do these things.